Good morning, students. In the last video, we discussed about chromophore concept using some example like conjugated dienes. Means how the lambda max are shifted towards right side. Now, today's topic is Frank-Condon principle. Okay, so before going into the depth of this topic, first we will see. We know that in the electronic transitions, what will happen, because the concept belongs to the electronic spectroscopy. In the electronic spectroscopy, what will happen? Excitation of electron takes place from ground state to excited state. Transition of electron takes place from ground state to excited state. But so that how would be your graph? Your graph should be like as a sharp peaks. Your graph should be like as a sharp peaks, like this. Very sharp peaks you need to get. Okay, but instead of getting a sharp peaks, we are getting a band spectrum. We are getting a band spectrum. Why we are getting this? Because during this electronic transitions, not only transitions takes place from one electronic level to another electronic level, as well as the transitions takes place from one vibrational level to other vibrational level. Similarly, the transitions takes place between one rotational level to another rotational level. Just I'll show you the graph here. See, energy curves for the bonding and anti-bonding molecular orbitals. See, this is the E1, that is lowest electronic state. E2, this is the highest electronic state. When you are sending this UV radiations, what will happen? Electron jumps from E1 state to E2 state. But this E1, that is lowest energy state, will contain some vibrational levels. See here, this dark line is V3, this is V2, and this is V1. Again this V2, see here clearly, again this V1 contains R1, R2, R3 like this. Again this V2 contains R1, R2, R3 like this. Again this V3 contains R1, R2, R3 and so on like that. Okay. Similarly, the electron, the higher state, energy state also contains vibrational levels as well as rotational levels. Means during these transitions, what will happen? Though electron changes from one level to other level, parallelly vibrational changes are taking place as well as rotational changes are also taking place. So that's why we are getting a bulk wavelengths which are very close together. So that's why we are getting a band spectrum. Okay, right. Now I will explain about this diagram clearly. See, let us suppose take a molecule. This is the internuclear distance. Take a diatomic molecule, which is the internuclear distance between these two, means where the attractions and repulsions are same. Okay. Now what we are doing is, first we are doing some compression, so that what will happen, this molecule will come to this place. With how much of force you compressed it, it will go that part of elongation. Now again you are doing compression. With the same force it will go elongation. Again you are doing this one. So in this way the molecule will start vibrating. Now I will explain it very clearly. Suppose a student is there. When you are entering into the college, you will sit at first bench. Okay, the distance between you and lecturers is like this. Next, what you want to do, you want to go for second bench. So the distance is increasing. Next, you will try to go for third bench. Next, you will try to go for fourth bench. Okay. Next, afterwards, if you are doing a lot of noise, what will happen? Your teacher slowly will tell you, go out. so that the graph is like this. Just one second. The graph will become like this. Means once this internuclear distance will become more and more, what will happen? The electron, the bond will get dissociate. Okay. So, if I tell that say example, then you will get more, I think, మీకు అండర్స్టాండింగ్ ఇంకా బాగుంటుందని చెప్పి I used this example. Okay, right. Now, generally during this electronic transitions, what is happening? Electron is jumping from one level to another level. So, let us suppose electron shifting is taking place from one level to another level. Oh, let us suppose this is the lowest level, that is E naught. These are what? V is equal to 0, that is vibrational level 0, vibrational level 1, this is vibrational level 2, and this is vibrational level 3, like that. Okay. Now, when the electrons are excited, bond strength is less. Means the internuclear distance between the atoms will become more. Here, this is the internuclear distance between these two. When it excites, the internuclear distance will become little bit more. So, this is E1. Here also we have what? V is equal to 0, V is equal to 1, V is equal to 2, V is equal to 3, V is equal to 4, like this. Okay, right. Generally, here the transitions may take place from any level to any level. Means transition takes place from V is equal to 0 to V is equal to 0, V is equal to 0 to V is equal to 1, V is equal to 0 to V is equal to 2, like that. Okay. Okay. So, I'll show here. This is the transition which is taking place between 0 to 0. This is between 0 to 1. And this is between 0 to 2. Again this is 0 to 3. Again this is 0 to 4. Like this. Okay. If you observe these changes among these transitions, from 0 to 2 transition will have more intensity. 0 to 2 transition will have more intensity. Say, during this electronic transition, we will get n number of peaks. But out of these peaks, all the peaks won't give exact data about your unknown compound. Only certain peaks will help us to know about the qualities, that is what is the functional group or how many conjugated systems are there, either it is aromatic. Such information was given by only certain peaks. Okay. So, here what is that certain peak? The transition from 0 to 2. So, if you observe carefully here, this is the internuclear distance. The electron is jumping from 0 to 2, means here also that is the same internuclear distance is maintaining here. So, that's why what this Frank Condon says us is electronic transitions takes place so rapidly. Electronic transitions takes place so rapidly that a vibrational molecule does not change its internuclear distance appreciably during the transition. Once again, I will repeat this definition. Electronic transition takes place so rapidly that a vibrational molecule does not change its internuclear distance appreciably during the transition. So if you observe here, the internuclear distance does not change here. Though it may undergo n number of transitions from one vibrational level to another vibrational level, but among these, the transition without the change in the internuclear distance will give us clear information or valuable information regarding our electronic spectra. So these are the different, anyway, what are these vibrational levels and what are these vibrational levels, what is the energy gap between these vibrational levels, these all concepts you will get in your IR spectroscopy. So that is very important principle. Frank Condon principle definition is very important for your exams.